Hey all, I think this is all started here. We're going to talk about equivalent rational functions, which is pretty simple. Equivalent rational functions looks like, for example, 1/2 equals to 2/4. They are fractions that are exactly the same. So in this case, we could take, for example, 15/18, and we could say, well, hey, that is 3 times 5 over 3 times 6. And therefore, these two threes, they're exactly the same. They'd cancel out, and we would get 5/6. But we can take that to be a little bit more complicated when we start bringing in variables. So for example, we could take 3x over a 9x squared. We know we have 3x, and 9 is the same thing as 3 times 3, and x squared, which is the same thing as x times x. And we can look for things that are exactly the same. And using the associative property mathematics, we can recognize everything's multiplied, and we can cancel things. We can say 3 cancels with 3, x cancels with x, and I can say, well, I'm left with everything's canceled on the top, 1 over 3x. I could take this just a little bit further, and I can say, let me erase some of this stuff that's on here. Okay. And I can go ahead and say, let's go a little bit more complicated. And I could say, well, let's look at 4x over x minus 6 and 2x minus 6. You'll notice that we have what we would call those factors again, the x minus 6 and x minus 6. We've got a factor. We've got a 4 over 2 and an x in the numerator there. And so what I'm going to do is I'm going to take that 4, and I know that 2 divides into 4. 2 goes into 4 2 times. Okay, I know this x minus 6 and that x minus 6 can cancel, leaving a value of 1. And there's this 1x that's just sitting up there. There's nothing on the bottom there that can actually cancel with it. So I'm going to say 2x. 2 goes into 4 2 times, leaving that in the numerator. X stays on the numerator because they're not just an x by itself. And then those x minus 6's cancel.